Surface chemistry short notes. Classifications based on interactions of phases. Lyophilic and lyophobic salts. Colloidal solutions in which the dispersed phase has considerable affinity for the dispersions medium are called the lyophilic salts. Solvent linking. For example, persons of gelatin, starch, gum, and proteins in water. Colloidal solutions in which the dispersed phase has no affinity or attractions for the medium or for the solvent are called lyophobic colloidal solvent. Lyophobic colloidal solvent hating solutions. Comparison of lyophobic and lyophilic property. Lyophilic solutions emulsoid, lyophobic suspensoid. Preparations. Lyophilic sol can be easily prepared by the shaking or warming the substance with solvent. Lyophobic sol cannot be prepared easily. A special method are required. Stability. Lyophilic solutions are more stable. Lyophobic are less stable. Reversibility are lyophilic sol are reversible and lyophobic sol are irreversible. Viscosity. Lyophilic sol viscosity is much higher than that of solvent. Lyophobic sol viscosity is nearly same as that of the solvent. Now, surface tensions property. Surface tensions. Lyophilic sol surface tensions is usually low. Lyophobic sol surface tensions is almost same as that of solvent. Property hydrations or solvations. Lyophilic sol these are the highly solvated as the particle have great affinity for solvent. Lyophobic sol these are less solvated as the particle have less affinity for the solvent. Property lyophilic sol lyophobic sol charge the particles have little charge or no charge at all. The particles carry a characteristics charge either positive or negative. Visibility particles cannot be seen under the microscope. Lyophilic solutions. Lyophilic sol particles cannot be seen under microscope. Lyophobic sol particle can be seen under microscope. Property coagulations or precipitations. Lyophilic sol precipitate by high concentrations of electrolytes. Lyophobic sol precipitate by low concentrations of electrolytes. Tyndall effect. Property Tyndall effect. Lyophilic sol less scattering. Lyophobic sol more scattering. Property migrations in the electric field. Lyophilic sol may or may not migrate as they may or may not carry charge. Migrate towards anode or cathode as these particles carry charge. General example mostly of organic nature. Gelatin, starch, gum is mostly of inorganic nature. Transition metal salt in water like gold. Now, peptizations, the dispersions of a freshly precipitated material into colloidal solutions by the actions of an electrolyte. Actions of an electrolyte in solutions is termed as the peptizations. The electrolyte used is called a peptizing agent. Hardy, a schulze rule. This rule states that the precipitating effect of an ion on dispersed phase of opposite charge increases with the valency of the ion. The higher the valency of the flocculating ion, the greater is its precipitating power. Thus, for the precipitations of uh, as S sol negative, the precipitating power of Al3 plus ion, Ba2 plus ion, and Na plus ions is in the order Al3 plus greater than Ba2 plus ions and greater than Na plus. Similarly, for precipitating FeOH3 sol positive, the precipitating power of FeCN6 negative 3 ion, SO4 2 minus ion, 2 negative ion, and Cl minus ions is in the order FeCN6 minus 3 SO4 2 minus greater than Cl minus. The minimum concentrations of an electrolyte in millimoles required to cause precipitations of 1 liter sol in 2 hours is called flocculations value. The smaller the flocculating value, the higher will be the coagulating power of the ion. Flocculation's value inversely proportion flocculation power.